Molarity. It's a method to express the concentration of a solution. It is, you might have heard of this, it's millimoles per liter. It's used widely, of course, in chemistry, but also it has uses in the medical field. It's, again, it expresses the concentration of a solution, or how much solute you have in that solution. How much solute you have in the solution. The equation is very simple. It's the number of moles of the solute divided by the liters of the solution. So it's moles over liters. It has to be in moles and it has to be in liters. So if it's not in moles, you have to convert it to moles. If it's not in liters, then it has to be converted to liters. So keep that, again, notice how dimensional analysis is everywhere. This whole unit can be written as capital M, and capital M means molarity. And it's read as, this many molar. So if I have something like a 6.0 M HCl solution, I would read this as a 6 molar solution, hydrochloric acid solution. So a few things to remember, that if you have grams or whatever it is, you have to convert to moles. And generally this is by dividing by the molar mass. And if you have mils, you want to convert to liters, you have to divide by 1,000. Or again, make sure you understand the other way around. So if you want to go from moles to grams, then you have to multiply by the molar mass. And if you have to go from liters to mils, then you have to multiply by 1,000. These are quick and nice shortcuts that we will use. Very well. So before we do this equation, go in and actually do this problem, very simple problem, the molarity also follows the same equation as the density did. It's the use of the triangle. So the moles would be on the top, and then you have the molarity and the liters on the bottom, or the volume. So if you would like to calculate the molarity, you would go moles over liters. If you would like to calculate liters, you would go moles over molarity. And of course, if you need moles, you would take molarity times liters. Once again, make sure you remember what this unit is. It's moles over liters. That's all it means. Calculate the molarity of when 6 moles of magnesium chloride are dissolved in a 12-liter solution. What does that tell you? That you have the moles, M-O-L. And of course, this is 12 liters. That's your volume right here. Luckily, it's in the units that we need. Again, it's not a bad thing. We should be able to convert very easily by now. So in this case, we have to calculate for the molarity. It's saying to you, calculate the molarity. It's a very, again, simple problem. In this case, we say molarity is equals to 6 moles divided by 12 liters. It's in moles per liter, so we don't have to do any conversions. Now this one has 2 sig figs. This one has 3 sig figs, so we need 2. And that would give you half, or 0.5. You got to put the 0. Moles over liters, which again can be written as capital M. You will see capital M written more so than before. Now, before we continue, this again can work as a conversion factor. So again, you have 0.5 moles over 1 liter, meaning you could be asked to calculate for the moles of Cl, since you have a ratio of 2 to 1 in in MgCl2. We will do these problems later when we meet. But for now, this is your answer. Now, this question is asking you to calculate the grams of sodium sulfate needed to prepare 450 mils of a 1.8 molar Na2SO4 solution. So it's saying to you, imagine you need for this reaction, industrial purposes, medical, whatever it is, application, you need 450 mils of a 1.8 m molar Na2SO4 solution. The question is, how do you prepare it? So let's actually think about it. Number one, you see mils, go ahead and convert that to liters. I would do that. Now again, you either divide by 1,000. So I'm going to show you exactly. So 1,000 mils, or I know you did, is 1 liter. You can reverse it. It would be 1 mil 10 to the negative third. That's really the same thing. So that would be 0.45 liters. So we have our liters ready. We have our molarity. And our molarity in this case is 1.8 m, which means 1.8 moles over 1 over 1 liter. Okay. The question is asking for grams. So if you're giving the molarity and you're giving the liters, then the only thing that's not found now is, or unknown, is the moles. So you have to calculate the moles right here. Well, a quick way, we say moles is molarity times liters. And that gives you the moles. And then when you have the moles, you can convert to the grams. We already know how to do that. So in this case, we'd say, okay, moles of Na2SO4 is 1.8 moles over 1 liter times 0.45 liters. The liters cancel out. And let's calculate. You just multiply 1.8 times 0.45. And that would give you 0.81 moles of Na2SO4. Now, you're almost finished. You just need to find the grams. So we need to calculate the molar mass of this. Once again, you go and you calculate this from the periodic table. So by now, I think we should be good with this. I'm going to tell you what it is. So that would be 142. Oh, by the way, let's go back up here. Remember, if we need to go from moles to grams, we multiply by the molar mass. So in this case, that would be, I'm going to write down the molar mass of Na2SO4, which is 142.05 grams per mole. So that's 1 mole, and that's 142.05 grams. So you're multiplying here, and the moles cancel out. And the answer would come out to, with 2 sig figs, to be let me use a different color here. It would come out to be 115, but we need 2 sig figs, so that would be 120 grams.